Team OLX, always dream.
Always questioning, taking risks, making mistakes, always learning, exploring, growing, succeeding, always welcoming, always listening, always making things better, quicker, easier, simpler.
Trying new things, helping reuse old things, always getting the nicer car, the dream home, the better job, always getting the best deal. Making an impact, looking ahead, mindful of the planet we share, always leading, never standing still. OLX, always.
Well, I like the prior slide the best because it's all about people. And thank you for welcoming everyone here. I'm Tim Davis. I'm kind of our CTO, and I do a bunch of other things at OLX. And just happy to be here tonight. Relatively new to Lisbon. I moved here about 6 months ago from Amsterdam, and I'm super happy to sit here with a fantastic product, data, tech, and marketing teams and building what I think is the future of how we do commerce in the world. So yeah, I won't take up a ton of your time. I think there's a ton of great content that our folks put together, and it's probably much more interesting to see the actual technology versus having someone talk about it. So I'll try to keep my remarks brief. So first of all, OLX, I don't know how familiar everyone is with the company. Obviously, I think people here in Portugal would know our major brands, OLX, Stand Virtual, and Imo Virtual. But we're a marketplace company, and we are super important part of the commerce cycle for re-commerce, for finding jobs, for finding apartments, motors, and all sorts of goods and services all through kind of our core markets. I think the numbers are somewhere around 12 million people come to our site several times per month, so we're almost always one of the top 10 kind of sites in any internet national market, which is true of all around the world, not just in OLX markets. But it's fascinating. And a couple of things I really like to talk about the technology and what we do. So we don't buy trucks. We don't buy warehouses. We're not actually moving things around the city. We're not buying real estate and renting out properties. What we're doing is providing a marketplace for people to find and sell what they want. So we're not leveraged around like physical goods. We're leveraged around fundamentally trust and matching up buyers and sellers. And that is a tech-driven business. And I like to think about tech and the impact that we have is we are solving human problems. I'm going to quote one of my colleagues. Pretty sure 2,500 years ago, whether it was in Egypt or the Near East or China, people still needed a place to live. So they were looking for a house. It may not have been the same way people bought and sold houses, but it's a human need, in the same way people look for companionship and social things. So what we are looking for, what we are all about as a technology company, is solving human problems differently, generally better than what's been in the past, which is an innovation-centric business. So again, the same way people had marketplaces in their local village or their local cities for thousands of years, we're still solving the same problem, but the reason we exist and that we're valuable to our customers is we solve that problem better, faster, at higher scale, more efficiently, and super importantly with more trust. That's, I think, a key part of any marketplace, and that's one of the things that OLX puts a lot of time and energy into. Now, again, since this is a master class on back-end engineering, I guess I'll talk about a couple of things I think are super fascinating about how we're solving the problems. One, I hope everyone here, I probably should ask for a show of hands, who hasn't heard of Gen AI? And if you haven't, just keep your hand down. It's probably embarrassing. So we are super invested in machine learning. And it's not just because it's a hype or a fad. OLX got a huge head start about 5 or 6 years ago with building a huge and super awesome ML-based infrastructure machine learning. So it's essential to our business. We operate at high scale. We have millions of listings per month people post of all sorts of quality. Tons and tons of people who are trying to do things like fraud against our users. Can't say we always get it right, but the only way we can operate a global marketplace at high scale is through machine automation and machine learning. So building upon that, we've actually put a ton of energy in the last year. So I think we've almost doubled our investment in ML and AI models, going from classic ML to now LLM-based things, to things like better suppress fraud, better actually moderate content, better detect fantastic patterns in our data to make better recommendations, and also kind of change the fundamental way users find and discover content. And those of you who used OLX perhaps or any other kind of e-commerce site, I'm sure you're familiar with the paradigm of like, I'll call it filter-based shopping. You go to a homepage, you select a category, you continue filtering down and seeing a reduced set of options down and down until hopefully you see the top 10 things that you want. We have a lot of great experiments that we're doing around going to, I'll call it intent-based shopping. So rather than making users kind of find the product, we can actually ask them what they're looking for, perhaps a birthday present for their niece or some like new apartment for their family near their school, and actually jump right to the conclusion of that through a conversational interface through LLM and other tagging technology. We're also super invested from an engineering standpoint, anything that makes us go fast. I'm not sure everyone would agree with me here, but I have a strong belief that none of us can predict the future. So again, if you can predict the future, come by my office and we'll chat more. But we're really committed to learning quickly from our customers and moving fast. So from an engineering standpoint, how fast we can learn, experiment, get data science and analytics, and then try something differently, is really the only sustainable competitive advantage I think exists in the technology business. Again, what we have today is almost always going to be outdated in 12 or 18 months, so it's about how fast we can create that innovative future. So we do a ton of work on things like automation. I think like anything that's toil, it's a word that we all hate, things that are manual labor, that aren't like driving innovative, creative thought. We spend time on automating it through our standard deployment tools, our automation through cloud technology, anything that can actually make us go faster and spend more time on customer problems and less time on tedious work is a super important thing that we invest in heavily. Similarly, we actually totally value things like innovation in mobile technology. So we're actually saying we're a mobile-first company. I think most companies would say something similar, but we're actually building a ton of things like design systems that automate code gen and take for our UX designers, the journey from going UX concept into production quickly, learn about the experiment, see if it works well, and actually go back to that high velocity cycle. So those are some of the things that we spend a lot of time on. Then of course, back to where I kind of started here is people. Like all this happens only through people. There's no magic like capital that we apply again for factories or buying real estate. Everything that we do operates through our people and actually how much we can turn the ideas and insights in their brains into actually customers' new experiences. So we do a lot of training, we do a ton of career development. We're all about ownership here. I don't really care much about job title. Actually, I care that people solve interesting problems. So when someone finds a problem, I'm always super proud of them to see them chase it across boundaries and make something great for a customer, or even make something great for an internal person. Our internal users and employees deserve a great experience. Even those of us who are working on enterprise IT systems or HR systems or finance all deserve a fantastic experience. I think I'm being told to speed up because I could probably talk all day, but I'll be self-conscious about that. And again, get out of your way and turn this content over to the team who's hopefully going to have some great technical chat.
Okay, thank you, team. Okay, so hi everyone. I hope you're prepared for today because I can guarantee that you have a masterclass with great talks and insightful talks as well. But let's start. I will introduce myself. I need the thing to the pointer. Okay. Okay. Yes, I need this slide to introduce myself. Okay, first, this is the agenda. Okay. So first we will have this introduction, and then we will have the talks, a coffee break in the middle, and then we will have Q&A and networking after everything. So, oops. So I am Camila, and here you can see a bit about me. So I'm engineering manager at OLX. I started my career in technology in 2006, and you will hear this number again, so keeping this year in mind. I'm from São Paulo, but now I live in Lisbon. I am dog proud mom, so this is my beautiful dog. I'm also a fan of martial arts, and this is my incredible team. And next month, I will complete 3 years at OLX, and I can say that it's it has been an amazing journey, and those people and you in this are incredible work with you, so I'm super happy to be part of this team. Okay, but now let's moving forward and let's talk a bit about OLX. So do you have an idea when we started our journey when OLX was founded? No? No, you can't. No? I told you that you will see this number again. So this is 2006. And this is the year marking our the beginning of our journey to make and to ensure that the second market, second-hand market, would be easy and help people to find things and to sell things. So we start in 2006. Now, those are our brands, and I'm sure you recognize some of them if you live here in Lisbon, in Portugal. So it's Virtual and More Virtual, and we are spread around the globe, as Tim said. And also, another question that I would like to hear from, I would like to see if one of you can find the right number. How many daily active users we have in OLX Europe? One shot. No, you can't. Not close. Okay, this is the number, 14 million. So yeah, and I hope you are one of those users. And then the last fact about OLX. So those are the place that we are, and all of these offs help and support our customer and also power our brands. And that's it about OLX, right? So now I have some notes, people, because my memory is not that good. Now that you know everything about OLX, or at least a bit about us, we can kick off our masterclass. And don't forget about join the Slido if you want to ask questions. As I mentioned, we will have a Q&A after the final talk, but you can start to share your questions here in this link, but you can also participate and ask questions here in person, okay? So, now, let's welcome Paulo and Ida. Applause, please. Just to introduce Paulo, I will need to read again. Paulo is one of our amazing staff backend engineer. He is skilled in several programming languages like Java and Go, and has extensive experience with AWS service. Now is the stage is yours.
Okay, thank you very much. Can you hear me out there? Yeah? Okay, thank you. So for today, I have something to share with you, our journey to contract testing through Pact. But first, things first. Do we have anyone that is familiar with, actually not familiar, an expert in contract testing or even Pact? If there is someone, please raise your hand. No? I don't see anyone. So so life has taught me to see things from different perspectives as much as possible. So this one provides me at least two different ways. So this is good because in that case, I can say something and you won't understand that I'm not really understanding what I'm talking about. So this is a good part, but it's a bad one. So as you probably are noticing, my voice, my sexy voice is not my real voice. So I'm praying so that my voice doesn't shut down and I'll be able to speak for the next 30 minutes. So who am I? My name is Paul Znida, as I mentioned before. I'm a staff engineer working in OLX for the last 7 years. My main functions, as Camila explained, so I'm a backend engineer mostly, but I'm also an SRE, and my main functions is supporting the teams that are working on my tribe, which is the department inside of OLX. In terms of loves, I love my family and being with friends. I had before some other things like Benfica, but I decided not to put them because I didn't want to raise any war inside here. And I hate dishonesty. That's one of the things that I dislike the most. Those are the contacts. And so for today, I'll be trying to keep you engaged and entertained for the next 30 minutes. I'll be explaining a bit about contract testing, Apparently, you don't know much about it. I didn't know what was the audience, so I tried to keep it simple, but with some code. I believe that most of us here are engineers, software engineers or software developers. So for me, when I was in that side of the room, I was expecting to see some code so that I could relate with what the person is talking about. So I tried to do that. The agenda for today, we'll start with the problem in the context, why we needed contract testing, why we are doing it in OLX, the main concept so that we can understand the same language. Then I will go with the status quo, what we currently have in Motors, the tribe that I'm working for. Conclusions and next steps. The Q&A is for the end of the sessions today. Hello, welcome everyone. Okay, sorry about that. I don't know what happened. So let's start with a quote that I believe it makes sense for today's session. This one is by Kent Beck, and he's saying, "I'm not a great programmer, I'm just a programmer with great habits." I believe that this applies to me. I'm not a big programmer, and my golden years are getting worse. So I'm losing my abilities to program, and I'll be a worse and a worse programmer through time. Hopefully, I will be able to compensate for that with other things that I gained from through time. And one of those are great habits that I've been learning through time. So problem and context, why do we need this? I'm going to read this together with you so that I don't miss anything that is important on the definition. I found this one in LinkedIn in this post, which I believe it's very accurate and get to the chase. So what is contract testing? It's a form of test-driven development in which expected interactions between two separate systems are defined, captured, and stored in a contract. So what does this mean? Tests written against this contract verify that both the provider is a service that is responding to requests, and the consumer, which is the service that is making those requests, adhere to that service agreement through the form of a contract. So what exactly is this and why we need it? In OLX, in our architecture, we have been seeing a growth in our number of microservices. So we have hybrid architecture, which I believe it's quite common out there, where we have a huge monolith that is being decoupled into several different microservices. With this growth, making sure that those services can interact with each other through time in a sustainable and not flexible, so sustainable and mature way is a challenge. So we need to set up and detect those potential changes when we are making changes in both the consumers and the providers before they actually reach production. This is one of the ways that for us to implement those mitigation steps without actually doing the deployment. And finally, there is a mixture or a balance between maturity and innovation. Contract test is not a new topic, but one that I've not been seeing that much being used in a lot of companies. I don't know how many people we really have in this session today, but around 40 maybe, or 30 at least. I don't know how many companies we have here represented, but no one in the audience today raised their hand, so this is quite common to what I know from the market. Although not being a new concept, it's a new for most of the companies. So this is innovation for Motors, at least. And in terms of maturity, because we want to deliver stuff, our software, being more mature. And through contract testing, we believe that we'll be able to do so. In terms of goals for both the company and for today, one of the things that we wanted to do, and we started this 5 months ago, more or less. So this is quite new, and this is us explaining and sharing with you what is our current journey. We wanted to better understand what is contract testing. That has been, for now, pretty achieved, I would say. But we also wanted to understand potential improvements and drawbacks in our ways of working. What is putting us behind our competitors? What can we do better so that we lose less time in finding bugs and fixing those bugs? For today, pretty much, I would like you to, at the end of this session, have more or less an understanding of what contract testing is and what can be some of the benefits, and if you can use it in your own company. Okay, so let's start with the concepts. What are we talking about exactly? This picture, take a look at the picture on the left side. Forget about what's written there because I'm going to explain. So we have 4 main components. We have the consumer, which, as I mentioned, is the service that makes a request. For the example of today, I will be using one service called Common Control Center, which is, in this sense, an HTTP client for a provider, which is a service that exposes ads to that service. Okay? So the consumer, and in Pact, we refer to this as contract testing, but usually consumer-driven contract tests. Why? Because all of the contract that is established, it starts with the consumer. The consumer is the first one that writes the expectations about the interactions with the provider, and from those expectations, which are written in one of the languages, so Pact is exposing to 3 different languages, multiple different languages, sorry, and by implementing those tests, the contracts are generated. Then we have the provider, which is the service that needs to say, I know the contract, and I'm able to respond to it. And by doing so, it can then publish to one of the other components, which is the broker. The broker is one component that is responsible for keeping in a centralized system the contracts between consumers and providers, and ensuring that each of the versions, for both consumers and providers, can be marked as this contract is fulfilled by that one. When it's fulfilled, it means that the consumer can safely be deployed because there is a provider running in production that can understand and answer to the contract that I defined with it. So this is pretty much the main difference. And finally, gluing all of those things together is the contract, which is the agreement between consumer and provider. Scenario for today, as I mentioned before, so the interface on the left side is what these two integration services pretty much does. The Common Control Center provides interface. The service ads is the backend service that is exposing the information for this service to show. Okay? Heads up, for this one, like I mentioned, I tried to keep the code as simple as possible. I didn't know what were the language, so I tried to use just one language instead of 2, so I used all of the services to be used Golang. And in the company, we have been using multiple different languages, including Kotlin, TypeScript, and so on. Just a heads up on this. All right, so consumers and providers, and we'll go through each of those. Each of those writes and they execute tests unitely on their own side, independently from each other. The only thing that they need to share then, it's on the broker. But from the perspective of both consumers and providers, they just run a test that runs locally as if it was any unit test that we are usually writing with a mock. The difference is that instead of a mock, it's going to generate a contract. It's also the responsibility of the consumer to publish, as I mentioned before, so this starts with it, to generate and publish the contract into the broker. Let's see how an implementation of a unit test in Golang works. So this is on the package of the ad gateway. We are using hexagonal architecture in Golang, so this is on the infrastructure with the gateway to be a HTTP client for the service, in this case, for the service ads. So there is one gateway, which is the ads gateway, and this is the test that checks for ads when they do exist. So this is the expectation of this test. Ads do exist. When I'm writing a test, the first thing that I need to always do is to initialize the Pact provider. So this is on the DSL, on the dependency that we have on the project. And after this, I need to specify the name of both the consumer and the provider. And this is very, very important. The names need to be consistent because it's based on those that providers know which contract to verify with. So if there is, for example, in this case, CCC, which is the Common Control Center, and ads as a service, there may be other interactions with these MGO ads and other consumers as well. So the Pact generated file needs to be this one. Keep also in mind the env or default value there, which is something that is fetched from GitLab. This is the pipeline that we are using, and we ultimately want to make all of this running in the pipelines that we have, so not just in the local machine. The names need to be consistent. So this line here is where we are generating locally the Pact file, the JSON file, and based on this, then we can publish it into the broker. Continuing on the definition of the setup of the test, then we need to specify the interaction. So this is where we are going to start defining the contracts, and I'm going to show you what's inside of that method in the next slide. But keep in mind, we need to specify the interaction. What is the expectation in terms of requests, headers, query parameters, what is the path, anything that is real important for me, for this service to communicate with the provider. After having this configured, we then need to execute that test. And after that test executed, before executing that test, we initialize the gateway client, the one that I mentioned before, with the host, which has been created from the Pact provider. So the Pact provider is going to run more or less an HTTP client server in the local machine, running in a given port, and this is what I'm going to use. Actually, it's mocked. Then I'm just going to make the request to the gateway with the method that I need to provide. And finally, the normal assertions. Heads up on this one as well. So in contract tests, we are usually focusing on the structure of the data. What are the fields there? What are their formats? Not exactly what is the behavior in terms of if the data is consistent with what I am expecting. So this is a small difference. It can also be used for behavioral, but usually it's just to check that the structure of the contracts don't change. Continuing, so this is the interaction. On the interaction, we start by saying a given, so this is the expected state that the provider needs to fulfill. What I'm saying here is that when I'm making a request to the provider, I'm expecting it to exist some ads there. So because I can say, and this is a happy path, I could say that I have an interaction when there are no ads. And the provider needs to be able to answer to those as well, probably not answering with any ads. So this is what I'm stating for the provider. When there are ads, and when I'm making a request on the get, through get, on the endpoint API view1 ads, with some query parameters, in this case the ID, and some headers, in this case xpartner URN. The expected response from you is a header containing the content type with application JSON, and the JSON body, which has a meta with a created at date, a name, and so on. And I'm not going into that many details on those, but there are different matchers. Matches are what we're expecting in terms of format. And in that moment, we see the created at has a date time generated. I'm expecting the format of the service to be this one, and not just a regular string. So this part needs to be fulfilled and guaranteed by the provider. If the provider isn't able to answer on this one, I'll be able to detect. On the provider, so provider does exactly the opposite of this. It fetches the pack that was published into the broker. It can also be using locally when we don't have a broker, but to scale out our solution, we needed a broker. So this is usually coming from a remote broker. Generates, runs the test against that pact and responds with this is okay or not okay. It's also the responsibility of the provider to update the pact on the broker saying, I was able to fulfill this, so please mark this one as being okay, and the consumer can check what is the broker result and say, oh, okay, cool. This provider is aware of what I did. Similarly, in terms of code, I have to provide the name of the provider, and this needs to be consistent, as I mentioned, on the consumer side. I provide, so this one is the ads service, right? And this service has the HTTP handler uses a service which is the ads service. And I mocked that service to be able to state exactly what I want the service to return. So this is the initialization of the mock. I need to start a server that is going to run locally on my machine in the host, on the server URL that I defined in the concept at the beginning. I'm actually in this start server, I'm just providing the handlers that I need, the service that I'm going to use, and this is pretty much the normal code that we do when we start a Golang server locally. Then we have the test provider contract, which, so the first line is version check version. This is, how can I say it? It's a rule of thumb. We need always to do that because this is the recipe from the library that we are using. Sorry. Then we start the server, as mentioned before. We initialize a provider, Pact provider, and we are going to make a request. In this case, we provide the server URL that we mentioned, the one that is going to start. We specify the provider name. In the state handlers, it's where I'm going to say, so this ads exist needs to match the given that I was defined before on the consumer. And this is what I say, oh, when ads exist, I'm going to configure one method, which is ads exist state handler, which is going to specify exactly what needs to be returned when that happens. In this method here, I'm just resetting the mock so that the expected calls between services can be refreshed. And like I mentioned before, so this part is already explained. When I'm going to run it, so this is a continuation of the previous one, the broker URL can be fetched from a remote or from local. Usually I have this broker-based URL defined locally when I want to fetch it from the remote. If I need to just put it locally, I comment that code and run it locally. This is important for knowing which versions are deployed and running in production, but I'm not going into the many details on this, so if you want to know more about it at the end of the session, please reach out to me and I'll be happy to explain what I know. Finally, we do the verify provider, and usually what it does, it's returning a no error, and if there are some pacts that were not fulfilled, the broker is not updated with those tests, with those successful. Sorry, to complete, the exist state handler is where I'm saying, when I'm doing a setup for the ads exist, I'm going to say that it's going to return 2 ads, and that's it. I'm not going to return any error, and I'm stating completely what I want to return. And this is, as I mentioned before, the happy path. The contract, as I mentioned before, the contract is a JSON that is generated from the code on the consumer. Don't try to write it locally. Don't try to write it on your own. You can just generate it and see how it looks like. But it's usually the best approach. Just write the code and then generate it. Sorry. So what is the anatomy of a pact? It has the identification of both the consumer and the provider. What are the interactions? And this is where we have all the statements down, the given, upon receiving, what is the expected request and responses. And we'll have as many interactions as the ones that we define. Based on my example, I only have one. And finally, it has a metadata which is irrelevant for our usage, but it's important for the lib that we are using, which is the Pact TSL for Go. On the broker pretty much has this relationship, so it will have both the consumer, the provider with the Pact, and all the assessments that it was done through time. And it's also responsible for triggering, I'm going to explain a little bit more on that one as an example. It's also responsible for triggering provider pipelines when some changes on the contracts on the consumer has happened. All right, so where do we stand on this? So we have 2 different merge pipelines per consumer. Sorry about that. We have 2 different pipelines per consumer and 2 different pipelines per provider. They are similar, but with the equivalent differences. So when there is a merge request, so we are just creating our branch and we have created a merge request, we put our code in the GitLab. The GitLab is going to publish the contract, it's going to run the test, and it's going to publish the test on the broker if the test succeeded. This is the first part. When I'm doing a merge for deployment, what I'm doing additionally is that when I'm deploying, so when I'm merging on master, and in OLX, we are merging every time and deploying every time that we merge to master. So this is our way of working and our way of releasing. We are using continuous deployment. Every time that we merge to master, it's going to be deployed. And when it does so, there is one additional step, which is marking that version of on the Pact broker, which this version of the consumer is now in production. So I'll be able to know which versions are in production. On the provider, we have pretty much the same. So we have the merge request where that the broker is, the provider, sorry, is going to download the Pact from the broker. It's going to run the test, and if it's successful, it's going to update the Pact saying it's already okay. When it's deployed, it's exactly the same as well. So when it's merged to master, it's going the default branch. I'm going to call it master main default branch because there was some time ago, I remember, a huge confusion about the usage of the word master, and it was being very badly interpreted. So I'm going to say default branch from now on. Sorry. So it's also tagged on the broker saying this is in production. And by the way, this is what we usually do to say, can I deploy to production? That tag. And if that version is already deployed, then I can say, oh, it's in production. So if I do a deployment on the consumer, the provider is already there. One more complex pipeline, and I'm not going too deep on this one, but still for you to be able to understand. This seems so simple that, oh, I everyone can do it, right? But there are things which are not that simple. For example, let us say that I already have one contract for one consumer informed, one provider, and they are both working, they are fulfilled, totally okay. Tomorrow I'm going to on the consumer, I'm going to do a change. So I do a change on the contract, and I'm going to create a merge request. It publishes the updated version of the pact to the broker, and this one needs to trigger the pact verify saying, oh, I have changed the pact. Can you please take a look if I'm not breaking anything? And the provider is going to do two things based on the configuration that it has. If it's a non-breaking change, so something for new, it's going to say, oh, it's not safe because I don't have that implementation on my side yet, so I wasn't able to fulfill it, but it's on you. So if you are just saying that you want to deploy, even if the provider is not ready, it's on you. But if I did a breaking change, the pipeline is going to say, no, 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 this cannot go further, because if you simply deploy it, it's going to break something that is already there. So this is a huge difference in the way that we have been working before. So this trigger pact job is going to update the pact on the broker with that information. And after that moment, the broker is going to say, okay, so the pipeline succeeds or fails based on the validation. And this is pretty much what you have set up now. And this is the most advanced case, I would say, and something that is usually hard for a new engineer to understand exactly what how this is working and why we need that kind of things. As I mentioned before, we are still in the beginning of our journey, so we are still learning as we go along. In terms of status quo, where are we in this journey? As I mentioned, we are still in the beginning, and before I'm explaining where we are standing, let me give you a high overview of our architecture. So we have, as we mentioned before, we have billions of users. I skipped that part, but we have multiple platforms. We have APIs, so we expose our systems for partners through our partner API. We have iOS and Android apps deployed as well. And we also have our web. Our system is composed, as I mentioned before, we have a hybrid architecture with a huge monolith implemented in PHP, which is still important. It's going to be important for quite some time. I've been around, as I mentioned before, for the last 7 years. And when I joined the company, the first thing that I was told is that, oh, don't worry, you are not going to work on the monolith. We are getting rid of it. 7 years has passed. It's still there, and it's still big. All right? But I've been seeing this story way too often, so just for you to understand. We are not alone. So then we have an interface which is implemented in Next.js. That's not a relevant part. We have a huge important component in our services, which is a GraphQL, which is a huge composition for all the services that we expose for the new interfaces. And finally, as I was saying before as well, we have lots of microservices running in Kubernetes, and we have those services getting more. We have more and more services of those. All of that runs on AWS as a platform. And finally, we expose all our platform into multiple countries. There is a note there on Kafka. We have also using Kafka for streaming and for event-driven architecture. This is important for one of the things that I'm going to say in a few seconds, or in a few minutes maybe, but maybe more accurate. All right, so in terms of highlights, and because we understood that GraphQL is such a big, important part of our architecture, our current journey, we are trying to put more effort in making sure that the tests for the communications between GraphQL and upstream services are made through Pact and not just through mocks. We have around 40 data sources that represent relationships with different microservices. And as of today, I believe this changed, but it's still a low value. We don't have that many data sources that have already been converted into using Pact. So they are using mocked. What does it mean? When a change in the consumer happens or in the provider, we don't know if it's going to work on production until we actually reach the production, or if we put it in staging and we have end-to-end tests and so on to make sure that nothing broke. And this is exactly what we are trying to avoid. Yeah, I think this is pretty much explained. On the microservices, one of the keynotes or the key takeaways that we got from here, so we have, as I mentioned, around 50 microservices. All of them are using one pipeline, which is a unified pipeline, the way that we've called it. So this means that every time that we need to change, we change one central repository, and all of the other ones are pretty much safe to be used. This pipeline is an adaptive pipeline in the sense that if there are some things that are in the project, then the pipeline runs. All of those services, by the way, are Golang. This was a choice that we made before, one that I challenged quite a lot, but in the end makes a lot of sense because it's now much easier for us to have maintenance, a lower effort in terms of maintenance, and just having one pipeline for all of the services that we have. So when we implemented that pipeline, we were able to touch and to make onboarding of new microservices to Pact in a very, very easy way. So the pipeline is the same. It's just a matter of implementing the unit test. And unit testing is usually something more or less simple, I would say. And so this means also the onboarding for new services is not that high. It's very simple to do so. The main challenge that we have here are really understanding some of the more complex workarounds on contract testing, as I mentioned before, and on Pact. And we are still learning as we go along, as I mentioned before, as well. So the conclusions, where do we want to go next? And this is what I said about that I would refer to Kafka. Expand or not expand? So this is the question. And nowadays, we are in the beginning. It seems that we are already gaining some benefits by having this kind of implementations. We are seeing issues not happening in production because we detect them early on, and we see some tracking of what are exactly the interactions between each of the services. By the way, and before you actually make the question, is this something that is an alternative to generate code from OpenSpec files and so on? It's not an alternative. They can be complementary, all right? So we can still generate the code, but this one gives me the freedom to specify exactly what properties I need, not the whole contract. I don't need to consume all of the things that one provider exposes. Maybe I just need 2, 3, 5 fields of what is exposed in that contract. And that cannot be used with generation and the OpenSpec specifications. One of the questions that we have already asked, but we decided not to invest on it right now, we need to balance our time in tech and in product. We are not a tech company as a single thing only, so we need to deliver value for our clients. So product needs to be in place. And so should we also try to use this for Kafka? Pact provides contract tests for Kafka as well. So doesn't need to be just REST HTTP client and server. And finally, one of the last questions that we have been asking ourselves is, should we start using contract first approach instead of implementing the code and then running the tests and running the contracts? I don't know, so I don't have an answer for this yet because we have been discussing it. But maybe if this approach gets mature enough, maybe we can start thinking about contract first. And even if we don't have anything implemented anywhere, we can start by making those contributions through contract first. And that's it for me. So thank you very much.
Thank you. I don't need this, but okay. Well, I know that you probably have a lot of questions to ask Paulo, so don't forget about Slido or bring your questions during the Q&A, okay? So now, let's welcome Daniela. So in a minute, so let's wait for Daniela, okay? While we are waiting for Daniela, let me introduce Daniela has been working at OLX for the last 8 years. They have a degree in astronomy and astrophysics, and they are also LGBT plus activists. So welcome, Daniela.
Thank you. Before all, hello all. I hope you are fine. I hope you are not sleepy and you are okay. Oh, thank you. So my talk will be about the backend development approach to Kubernetes deployments. So basically because I started as a backend engineer, and so in the last times I've been working also as Paulo with some SRE skills. So I think it's important to mention this in the step from backend to SRE and stuff. There is anyone that is familiar with Kubernetes? Okay, some people, which is good. I'm talking about fundamentals, so there is some stuff that is more easy or the other stuff that is more complex, so let's see. Like for today's agenda, a little about me, how you get here, a little about Docker because it's the basis of Kubernetes, Kubernetes and backend development and Kubernetes. So about me, my name is Daniela. I use they, them pronoun. I'm backend engineer for the last 7 years on OLX, 7, 8 years. I work with SRE core tech team for the last 5 years. I'm work at the engineering experience team at Motors, and I'm a proud mother of 2 cats, Misako and Emi. They are little, but they are very cool. I'm actual president of the board of Filgo Portugal, and my contacts are there, daniela.bento@olx.com, and my website if you want to see stuff that I do or write, or if you have interest. So, how we get here? So basically, in our way of working, we should want to speed up our deployments. We want to detect errors faster before going to production. This is very important because I know that everyone should have that time that they could do some changes and go to production and, okay, I broke everything. So who has happened that for someone of you broke systems? Yeah. Many times. It's usual. So we want to deliver faster, we want to deliver without errors, we want to deliver products with benefits for everyone, for the coders, for developers, for the engineers, for the product itself, for the clients. So there are small steps for going to production. So you should get developing code. And you should do your respective tests. And after revision, I hope everyone revision your code and have pull requests with thumbs up. You get your code merged and you start the pipeline. And you go for the CI/CD, as Paulo mentioned, because here we use continuous integration and continuous development, and you go to production. So, and how you guarantee that anything is broken in the middle? So you test. Unit tests, integration tests, pack tests, etc. And this all happens for guarantee that the code is not broken in production. Because the last thing that you want to know is that the client complain about an error that you cannot see because the system is broken. So for historical context on this, like I'm pointing, like, traditional deployments was done in a physical server, and we have multiple applications running on a physical server. And this has the problem that we are not containing anything. So the applications can, for example, if you have 2 applications running on a system, you can have an application eating all the memory, and the other application goes down because it does not have memory to continue to run. So this causes a lot of problems in production, this causes a lot of issues, and so in the next model, in the deployment virtualized, we have a little change. So we have an hypervisor, and we start deploying inside virtual machines. So we have a big physical machine, and we have lots of virtual machines with your architecture and your design system contained in each virtual machine. So you have an operating system for each application inside the same system. So in this way, the applications are still are now separated, but they are very rigid in terms of operating system, because they are not sharing anything except the physical machine. Historically, after that, we start using containers. So what means that we have operating system, but it's more relaxed in the sense of the uses of the operating system. So what's happening is that we have an application, we have the libraries, and after that, we have the common part of the operating system that is used for all containers. Let's see. I have to talk a little slower. So why we begin? Like the common usage for Kubernetes is using based on Docker. So let's begin with Docker. So Docker brings us a way of putting things together with dependencies, everything making it easier for the developers to create and deploy applications across different platforms because Docker is self-contained system. Okay, thanks. So in this way, Docker is a very lightweight, it's portable, it's self-sufficient, and has all the things that applications should use to run libraries, dependencies, everything, except the main core of the SEO because it's shared with the operative system. And in this way, what is the steps for doing this? So we build a Docker file, we build it, on top of it we create an image. This image is published somewhere, and you run it in the container. So what is a Docker file? Basically, it's a set of instructions that build up our system with dependencies, with everything. And it creates an image that is the object, the final object. It is a read-only object that is published somewhere. And in the end, we put in the container and run it. And this container can have multiple functions, deployments, applications, everything that you want to run on it. So the idea is that this image can be portable, can be configured anywhere, and can run anywhere. So for example, in our case, we use AWS, we publish to AWS, and then in AWS, we publish to our Kubernetes system. So basically, this is an example of a Docker file. We have the definition of the system of operative system, the download of the system, the dependencies, and this is a simple way of making a HTTP server running on Nginx. If you see, we have a little underline here because normally it's good practice to stick on versions, and this example does not stick on versions, so it's like a way, it's a good practice. Like, it's important. So we build up our image, and its use can be used anywhere. So there is two ways of sorry to simplify. There is two ways of building and sharing the image. You can do for a registry. You push your image to a registry and use it, or you can tarball it and share it as a simple file and download in another computer and run it, publish there. So these are the fundamentals of running a Docker. So you can see this image. We can run in a HTTP server in a 80 port, and you see this is an example of OLX Masterclass. So Docker file in 4 steps. Write Docker file, build an image, run in the container, and ship it. When you ship it, we have it ready for running on all the systems that you want. And it's ready to run in the Kubernetes system in the future. So, in the step before Kubernetes, we also have Docker Compose. For those who does not know, but Docker Compose makes the possibility of you to use many systems inside your local environments with a lot of containers, and everything communicates with each other. Because sometimes what is happening is that our system is trying to start making it so complex that it's difficult to maintain it running locally with all the things that we want. For example, web servers, microservices, dependencies, databases, cache servers, etc., etc. So Docker Compose permits that all things can get together and run it easily. And basically, the recipe is the same. For Docker Compose, wrote a file that is a set of instructions that build up everything, publish the image, and everything runs on the container. So, for example, this is a simple service that runs a Redis service with a web application in Python, and it will basically show up a counter in the Redis file. A hello world for the Docker Compose. But this is the example. So as you can see, we have the Docker file, we create images, we run in a container. But we also can push it to the register, for example, Docker Hub or others, or GitLab register, and run it outside your computer. And now, Kubernetes, as known as K8s. So what is Kubernetes? Who can answer me? In 3 words. Good. More opinions? Oh, you. Yeah. So basically, Kubernetes helps us to orchestrate containers, all the systems in our platform for a future usage and for the production, for staging, for every environment that you want. So it's running, it's a huge system that is growing up very fastly because it has a lot of functionalities, a lot of ideas that are coming up with these tools that are widely available. That is a very composed program that is amazing because it does a lot of things that we normally should do manually when we have physical servers that we have to change stuff, and Kubernetes do it all together alone. So, for example, if your deployment dies, it restores automatically. If your database is dying, it knows what to do with it. I always, sorry. Sorry, people at home, because I'm always falling down the micro. So, for Kubernetes, we have an easy deployment, resource utilization, horizontal scaling, also vertical scaling is also possible in Kubernetes, and zero downtime. So, why it's easy deployment? Because instead of deploying everything manually, Kubernetes can manage all of this for you. You can put your image, you go to the register, you make it deploy it, and it will deploy without any manual touch for anyone. Resource utilization, this is very important because as Docker can be also used to maintain your container limited in space, memory, and physical problems, stick to physical properties. In Kubernetes, this is also happening, and you can set up that application only can use 5 gigas of memory, 1 CPU, and nothing more. And after that, it starts killing itself, saying that it's not having memory to continue, and other applications on the Kubernetes system continue to be running without any problem. Horizontal scaling. This is very important because if we have a deployment that is being killed because exceeded the memory, because the system is trying to fill up a lot of things, you can automatically make it horizontal scaling that create another pod, and with another pod, it will respond more traffic more easily with more things. And zero downtime. This is a tricky one because not many times you can do a lot of changes with zero downtime, but you can ensure that you can reduce that time to zero, nearly zero. So the idea is basically we have strategies for that, Canary, blue-green deployments, and you can do it for short-term and ensure that your deployment is going well to your production environment. So Kubernetes components. It has nodes. The nodes are the principal unit of Kubernetes. So basically, the node could respond to what we should go for a physical server. For example, the web, normally we have for the Kubernetes at least 2 nodes, for the master node and the worker node, but it's possible to run it with only 1 node. The workloads is everything that is run inside the Kubernetes cluster, everything that gets memory, gets usage, gets CPU usage, etc. The namespaces are definitions that you can address for your application to be more structured inside Kubernetes system, because you can have multiple deployments with a lot of systems and you can divide them by namespaces. The storage is a mess because normally when we are working with Kubernetes locally, mounting systems is not easy as sometimes we can think. Services that expose our pods to our system, to the world, and the deployments that the unit that get the pods and define all the structure of your application. So, this is the architecture of Kubernetes. So as you can see here, you have the master node that has the control plane that has everything that controls Kubernetes. And you have the worker nodes that has the true workloads of your application. So the deployments, the kubeproxy, and everything that runs on your application that goes to the end user. But with this, it's possible for you to use at your local machine with Minikube. It's a faster way of learning Kubernetes locally. For the people that use Linux, I recommend not using Minikube. I recommend to use K8s that is lighter on this because it's a little more softer for learning stuff and is not having a lot of problems with mounting points. And when you talk about backend development, so my approach to Kubernetes starts on backend development, so it's why I get my experience. So, but basically the idea is like Paulo said, we want everything in pipelines because it's our process, it's CI/CD, we want stuff to go to production automatically without manual work. So our way of working is build, testing everything, and pushing to production via Kubernetes cluster. So using all the mechanisms that you want, that you can have for it. The normal GitOps operation in CI/CD Kubernetes is like developers push the application for the repository, the pipeline builds, the image is pushed to the registry, it's deployed to the Kubernetes via GitLab, Jenkins, etc., etc., etc. The other applications that can deploy stuff to Kubernetes. Not only GitLab, not only GitHub, but other applications. So, this is, for example, a process of who is familiar with the Argo CD? Yeah, a lot of people. That's cool. Argo CD is custom resources for Kubernetes that has a lot of potential because it does a lot of things inside the cluster. So in OLX, we use Argo as our declarative GitOps operation for Kubernetes. And it means that we can have deployments automatically generated for each environment that you want, cluster that you want, everything. We can use customize, Elm, JSON, and YAML, etc. to configure our system. And we have rollouts and rollback systems for all the platforms that we use. So the architecture of Argo CD is based on custom resources. So we have the main Kubernetes system that deploys everything to the production, but we have operations like sync operations, we have application operations, we have also application operations. We have a lot of different operations for the application itself. So for example, when we push to production, we also have to sync the application and to make it read the last manifest of the system. And so this is the example of the Argo CD on the pipeline. So the commit, the changes are done to the code, the image is pushed, and after that, the cluster will read the manifests that were updated and updated it automatically on Kubernetes. For example, this is an example of a dashboard of Argo CD. It's very pretty. It has a lot of details that is nice to see. But Argo CD itself is not enough. Argo CD needs something for us to make sure that the system is deployed in conditions. So we use Argo Rollouts. So Argo Rollouts can make deployments in blue-green methodology or can do in Canary. So this can be good because you can make the traffic shifting very smooth and very easily for the production environment. And we have metrics integration, so Prometheus, Wavefronts, Web, Kubernetes jobs, Datadog, etc., etc. So it's very important that we have metrics to ensure that our application is going to production in well conditions. So basically the architecture of Canary rollout, of the rollout on the Kubernetes. So basically the idea is that we have a controller, a Kubernetes controller that is done by the rollout. And what we'll do is to make sure that we run an analysis template, or that we have a description of the template that make the analysis, and we'll try to ensure that the new system will comply with that analysis. So for example, if you have a metric saying that the system should not fail less than 2% of the requests, if not, the system will fail and the system will not go to production. So this is important because we ensure that when we are deploying stuff to production or to staging, but mainly for production, we ensure that we have no more errors that we have before, and we ensure that we have good conditions to go, and we are applying for a better improvement. So this is only a dashboard for the Canary, but most importantly is that, for example, it's important for you to, in these methods, also have notifications about what is happening in the system. So Argo CD has notifications, and Argo Rollouts has also notifications that can ensure that everything is running and fulfill with your desires for that application. So, for example, this is a YAML file that is Argo CD notification that can show you, for example, when an application is synced and is okay to go. And you can trigger it, for example, for Slack, for email, for another components that you feel that is important for your system. This is a test application going to Slack. But Argo Rollouts also can do this. And this is very important because, for example, if you have a rollout that is aborted for some reason, you can have a notification saying that the rollout was aborted and stopped, and you know why. And for example, if it's possible, you can integrate this with the New Relic, for example, and has all data of the aborted rollout on New Relic and see what is happening with the system before trying to go for finding a bug somewhere else. So this is an aborted example with the GraphQL that is showing that the failed step was the first one to fail. So it's a problem nearly in the first time, so basically it's a hard problem. And with these notifications permit us to make sure that, for example, if you use a blue-green update strategy or a Canary update strategy, we ensure that the systems are okay. So, for example, in this example we have a test that is pushed for the Canary. We wait for some time. The Canary will run a test. We'll get information from New Relic. And if everything is okay, the flow goes and the Canary will not stop the service. Basically, the idea of the Canary for regions, like the blue-green approach will be making the shift of the traffic all together from one fleet to another fleet. And the Canary, what we'll do is pushing one pod, testing that pod, if everything okay, pushing another pod, or the way that we want to push for the system. For example, we can push 100% in this case because it's staging, we push 100% and we test all the system. But we can push only 25%, 60%, 90%, and after that, 100%. And for example, the application now is deployed. And for example, in this case, we have some jobs here. What these jobs do is like to entitle the application and generate more traffic in top of staging, because normally staging is an environment that does not have so much traffic that you want to test. So you can push more traffic to staging, pushing more with this type of jobs, and simulate the system. And with this, we can have metrics for Canary to show up and go forward with the system. So, next steps. This is a challenge. Running Kubernetes locally. Who have this experience of running Kubernetes locally? Who do you feel? So sometimes it's not easy. So other times it's fast, depending on the system. But we have a new excuse because now it's not working on my machine, it's not working on my container. So, thank you.
Thank you, Daniela. Okay, people, so I hope your energy is high because we still have a talk, a really nice talk. But before, let's have a really short coffee break. So please feel free to grab a coffee, tea, some cookies or water, and then in 15 minutes, be back here, okay? People in home, you can also grab a cup of tea and coffee, and then in 15 minutes, we are back. I don't know why I was... Okay. This is really weird.
Epa,
I
já
missed
está
my
safa.
mic.
Ela também já está safa.
Can you hear? Really?
Yeah.
Well?
Can you
Okay.
hear? Oh, okay.
Oh.
I don't speak more.
Ah, you. No, I noticed. Sorry.
So no issue
Okay.
for you on this.
Okay. So people, now it's time for our last. Jesus. Relic.
Don't know.
Okay, safe. So now it's time for our last talk. After the OLX talk, we will also have the Q&A, and then we will have pizzas and drinks. So, yeah. Okay, so let's welcome OLX. And let me introduce OLX.
Oleg.
Yeah, has been with OLX for 3 years. He mostly works on backend development, but he really enjoys all parts of the development, software development. He's not, when he's not working, we will probably find him spend time with his family and friends.
Yeah, exactly.
You're welcome.
So, hello everybody. I think you just spare my work. I did all the introductions. Actually, have not much thing to say about me, but yeah, that's me. That's me 10 years before. That's an old photo. That's me right now. So, backend is hard, as you see. But what I do, well, mostly just, writing some code, reading some code, sometimes fixing bugs, not always mine, and creating some docs, sketching diagrams, typical backend stuff. Where I work, generally here, OLX, from everywhere, but we are based in Lisbon office. I'm not working. As you see here, it never happens. No, I'm kidding. Just kidding. I love spending time with my family, with my friends, laying down on the beach, on the couch with my wife, watching some movies. Actually, I have a couple of familiar faces there also. Really nice to see them. And where you can find me, on LinkedIn. So please connect. Let's stay in touch if you would like so. And what I'm here to do today, well, the goal is to tell you the story of our team, the story of MarTech, also known as marketing technology. I want to tell you the story how we designed, how we built, how we scale our services to process billions or zillions, no, just kidding, billions of data and ensure millions in revenue for the company and also provide the value, of course, for our customers. So the agenda today will be about this. First, try to explain this a little bit cokey title, I know, and then, of course, focus on our development journey, try to explain in more details in the way it's possible how we are designing, how we're building, how we are scaling our services. And the end, of course, also to explain you how we assure that all the stuff that we are doing here in the OLX keep rolling 24/7, basically. We'll talk a little bit about keeping the lights on. And of course, some final thoughts, some key insights, and kudos. So yeah, try to not get sleep, because there will be food also later. So yeah, starting with the first part, the million-dollar problem, and why we call it like this, why using such a cocky title. So our problem is to make people uncover OLX. What does it mean? We want basically all of you here to know what is OLX. We want you to use OLX to solve your real problems. So practically speaking, what we want acquire new users. We want engage new users, growing the activity of our users. And of course, we would like to reduce the users that are stopping users using our platform. So we want to retain you. That's what we would like to do. How we do this? We need effective communication. We need to have some effective way to target our customers, our users, through email channels, through push notification, through text messages, and what other channels that we might have nowadays. That's our goal. That's our big problem. And actually, that's why I'm saying if you solve this problem, that's $1 million problem. It generates revenue. So, but there is another problem. That is not our core business. Because as was saying Tim in the beginning, we are a marketplace. That's where we have more value. We are selling ads. We allow people to put ads. We allow people to enter our platform, buyers, sellers. That's what we do. We are not a marketing platform. We are not, we are not a telecom company to communicate with other people. So that's an issue, actually. So how we solved it? Well, that's where our development journey starts. What we did, first we tried to realize how to focus on what actually matters, and try to delegate the rest. And that's when we realized, okay, we are not good in sending the final communications to the users, but we are good on other stuff. So that's where we found the right tool for our purpose. And ladies and gentlemen, introducing you here the Braze. I know we are here to talk about the OLX. I'm talking about the other company, but actually that's a very nice platform that you can use for solving your problems like marketing communications, targeting different kind of users. Just in case to be sure, who here ever heard about Braze? I'm talking about Braze and not the other sites that you might thinking about. So yeah, just keep that in mind. There is a confusion. So basically, that's a tool, that's a platform, cloud-based platform, where you can use it to send any kind of communications to users, like Android push notification, iOS push notification, text messages, emails, WhatsApp, and so on and so on and so on. So we find the right tool. And actually, it helps us a lot, because we can track our user activity and reach our user through that platform. This is just a screenshot. I hope you can see it well here. But you basically, this is like an interface of a typical user profile, just to let you know what we know about you when you're using our products. We know your name, we know your email address, we know some of your attributes on the user profile, like your company, for example, it's a company user. We know your custom events, we know the activity, we know that you click on the ad because you like that ad. We know that you unclick of the ad because you don't like that ad. We know when you view some page or when you publish some ad and so on. So that's Braze solves this problem. We can store all this kind of information. But not only, we can also build personalized messages to target our users. And that's the part the marketeers love it, basically. You can have like an interface like this, where you design a message that you would like to send for a user. This one is an example from Portugal. Basically trying to promoting the value-added services. Basically when you can add a feature on your ad and make it appear on the top of the search, for example. Yeah, make you basically kind of a cheater for the ads. And yeah, they can write this. And you see, they can put placeholders, different kinds of data. And where is all the data come from? It's stored, as I was previously saying, in the user profile. So you might think right now, okay, so the talk is finished, job is ready, goodbye everyone, but not so easy. We have the second, I would say, the secret ingredient, and that's actually where the problem starts. Let me say like this. We have the rest that is about billions of OLX data. As you can imagine, as Camila was showing in the beginning, we have a lot of multiple websites. Just in Portugal, 3 of them. In Poland, also 3 of them. We have in Bulgaria, Romania, and so on. Each of sites used daily by users, generating tons and tons of data. And our problem, our challenge, is to send the data to the Braze. And we need to be sure that we don't lose any data, that we do it in a safe and legally compliant way, because, of course, you trust your data to us. So we don't want to disappoint you. So we had a plan about this. And what we started was thinking, okay, let's try to put some abstractions here. Let's try to think globally, what we will be doing. And we realized, okay, we need to figure it out and discover all the data sources in the OLX. We need to discover, actually, how we can stream the data from those data sources. We need to build a service or a set of services to export the data to Braze. And on the Braze side, you will see basically, as I was showing the previous slide, all the users' attributes, events, purchases, what users buys, and so on. So the challenge actually starts here. So first step, defining the architecture. Just a warm-up question. What do you think this kind of system needs or requires? For example, you have a website, generates tons of events, millions. What do you think you should be aware, to keep it working? For example, anything that occurred to your mind? What do you think about, for example, if you did a payment and for some reason we send it twice or 3 times to Braze? That's a challenge. What do you think about, for example, if we need to provide this tool to the marketeers, right? And the marketeers are quite annoying people because they are always asking us for more data. They are always asking us for different kind of data. When we think that we deliver what they need, they remember to say, no, but I need another data point. I need another type because I want to send a different kind of email to the user. So actually, here we have our first requirement, which is flexibility. The system must be flexible in a way that we can add new data points in an easy and a fast way. Just also clarifying here, I hope everyone is aware what is a data point. Data point is just an abstract way of saying piece of data, like an event with a name and a bunch of property likes. Like, for example, Paulo did a purchase, and the attributes like add ID and so on and so on. So yeah. The second requirement is scalability. As I was saying, like the system needs to process high amount of data across multiple countries, across multiple business units, must be supported. And once again, because we operate in many different countries. The system must be reliable. The data flow between OLX and Braze must be continuously assured, like 24/7. And really 24/7, especially because there is some legal issues if we don't update the data correctly. As you know, in Europe, if you just unsubscribe from an email, and for some reason we didn't update that information, and you receive an email, we are legally breaking the law, the RGPD law in Europe. So that's, you see the importance of be 24/7 monitoring our systems. And then the security, of course, ensuring the legal compliance, as I was saying, our OLX security standards, and the costs, finally. All this costs money, and imagine storing so many different data, it costs a lot of money, actually. So we started thinking, okay, we have this big problem of exporting data to Braze, how we should handle it. And we understand that there are that we should divide it and break down it into 3 parts, like generating the data, exchanging the data, and actually exporting the data. So let's start with the data generation process. Just a warm-up question here. Have everyone or someone here heard about what is a data lake ever in your work? Yeah? Nice, nice, nice. That's cool. That's cool to know. So as you imagine, we need a data lake in our company. Putting it simple for those who don't know, think of this just as a bucket. In our case, it's just an S3 bucket, giant, huge. Like we put everything there, tons of files, JSON files, Parquet files. Parquet is another format of files. You just put it there. All the activity is stored there. We have a global data team in OLX that help us with this. Actually, they manage it. So, but as you can imagine, we can have there a lot of different data and private data. So nobody can access it. So that's why it's organized in a hierarchical way. We have reservoirs. And what are reservoirs? Are actually also S3 buckets. Basically, buckets where we organize data hierarchically. We have a bucket, for storing users' data. We have a bucket for storing ads, like that people publish. Have the bucket that stores payment data. And we also have our bucket, Martech bucket, that we created for storing all the data from others' bucket. But still, that's not enough, for generating all the data that we need. Because, let me put you the challenge. Let's suppose that tomorrow a marketeer knocks your door and say, look, I want to send an email to the user that I know that checks some ad, and tomorrow the price of that ad changed. Like the user was checking iPhone, and tomorrow the price changed, and the user wants to know that this happened. So how you would orient yourself in all that amount of data? You cannot just go, to the bucket itself. So we have a tool for that. We have a data integration tool. Basically, we call it OLX our data integration hub. And for folks that are here from OLX, we call it Odin, basically, that can process huge amounts of data for us. For those that perhaps might know, under the hood, we use a framework, which is called Apache Airflow. Somebody here ever heard about Apache Airflow? Nice, I see here some data people, that's cool. So yeah, what is Apache Airflow? Basically, it's just a tool for running, but put it technically, running jobs. Or you can call it running DAGs, or you can call it directed acyclic graphs, just the pipelines, workflows that you define. And each workflow, you can run any kind of stuff. You can run some SQL code, like you can run some Spark code. You can connect to the external databases like a Redshift and so on. So yeah, really useful. So we use that tool. We process every day multiple pipelines, make the computations, calculations that we need, actually, and then we export the data to our reservoir that we have. But that's only the part of generating the data. We are still missing the part that, okay, before you export something, you need to exchange that data, right? How you exchange it. People will not connect directly there. So in OLX, once again, thanks to our amazing global data team, we have another tool, which is Kinesis Streams. Everybody here, just to know, who used Amazon Kinesis ever? Experiment. Nice. I like making discussion. I see a lot of people using the stuff, so that's really great. So we use the Kinesis. For those who are not aware, think of this like a huge infinite array where randomly we put data. Each piece of data has a sequence numbers. By data, I mean you can put here like, actually it says here, you can put here like JSON records. And the JSON records here could be a metadata about some file inside the reservoir. And why it's useful? Each time some new data is generated by this giant flow, you will know that a new file, a new piece of data arrived to our bucket because there will be an event here to the Kinesis stream. So we solve the problem of data exchange. Or not, actually not. Because what if I told you that you need to exchange the data in real time? What if I told you that somebody did a payment in OLX and I want instantaneously send this information to the Braze, to send the email to the user? I don't want to, to waiting these pipelines to working. Some of them can take a day for working, and some of them probably will only grab the data from yesterday. So how I exchange the data in real time? And that's actually where enters Kafka. As also Paulo was mentioning in his presentation, that's something that we are actually using here. So as you can see, we can have different OLX domains, once again, users, teams responsible for the user, for example, ads, team responsible for the ads, payments. And we can all communicate together through Kafka. Sometimes when talking with product manager, I'm just saying, think about Kafka as a Slack, but for the backend people, So yeah. And what do we have next? So forget about the last part of the presentation I was doing because that doesn't matter anymore. You just need to think that we have on the left side a data streams, actually two streams of data. We have a Kafka data stream with a lot of events there. We have our Kinesis stream. And we want to design a service. Let's call it Braze Service because we want to export data to Braze, right? And we want to do that through the API. So that's where I would say the challenge of the billions of data points actually starts because this service grabs a lot of different files, events, and need to export it. And assure that we are always aware if something wrong happens. So how we started to do this? First, we need to figure it out, okay, where we will run it. And here I could ask Daniela, just come here, explain once again what is Kubernetes. But I hope you were all paying attention and you remember what is Kubernetes. And that's what we're using for running our services. So yeah, we have an execution environment. What we do next? We actually build a service, a microservice. As you saw, here in OLX, we develop a lot of different microservices for different domains, for different purposes, and that's what we did. The next question, what to use for building it. In our case, it's not Go. Some teams using Go, very used here. Other teams using Kotlin. So another question, who is using Kotlin here? One person? Android engineer? No, okay, backend. Okay, then. Just curious. Okay, who is using Java here? Okay, so you know Kotlin, but you don't realize it yet. So what we have next? But that's not enough. Of course, we could only work with the Kotlin, and that's good, but that's not enough because there are very nice frameworks that we can use. And in our case, we use Spring Boot. So last question, I promise. No, I'm not sure. I mean, who uses Spring here? Okay, cool. That's amazing. So that's what we did. We built a service in the Spring Boot, actually. Now we have a service, but once again, remember what our service need to do. Need to connect to external data streams, Kinesis, Apache, Kafka. Consuming payloads, JSON from Kinesis, Avro from Kafka. I think I didn't mention Avro. For those who don't know, Avro is a very accepted in the community format of the files used in the Kafka events, not only Kafka events, but other stuff. We use basically, once again, Spring. There is a great connector for the Kinesis in Spring. You can set up your connector to the Kinesis stream just by basically importing the dependency in your Maven on your Gradle and putting some properties in your application file or some annotations. It depends on the versions that you're using. And the same similar for the Kafka. You can very quickly and easy connect it. Next part, what is the output? The output is Braze, right? We connect it through the APIs. And once again, Spring helps us a lot here. We very quickly set up a Spring Web client, just literally one class. And you can put an endpoint that you want to connect. And of course, we expect it works. But that's not all, because from the input to the output, there must be some connection. What if the data that comes from these streams is actually not in the format that I'm expecting? And the format that Braze accepts is actually different from the one that I have in the input. So we need to do, of course, some data mapping. That's putting very simply, that's what our service do. What's next? You might say, wait, that's all? Actually, no. We have problems. How about avoiding sending duplicates? Because once again, here, when I was showing you this, you could assume that this system works continuously. It never breaks down, that you're always sending the data. But let's suppose that the service is down, like Braze is down. You know, we will accumulate data. We will not be able to send it. You know, what suppose if there is a problem in upstream data that arrives to us? You know, what if there is actually some duplicates there? What if there is some outdated data, expired data? Like, for example, let's suppose you updated your user profile with your name. After 1 hour, you updated your user profile again. And if our system were down, we don't care about the last, we only care about the last time you updated your user profile. The rest, it doesn't matter to us. So we need to discard changes that are outdated. And finally, okay, we need to reprocessing the data in case of failures. And failures occur pretty frequently. Not only because Braze is down, because we are down, because some other team that developed the service is down. So yeah. So what do we need here? Okay, another question. Who have ever heard about idempotency here? Nice, all backend people, love it. Okay, so I don't need to explain it, but I hope you understand why we need it actually, because without idempotency, we couldn't reprocess the data multiple times. Because if you reprocess the same data multiple times, probably the second time you will see a bunch of errors, bunch of problems, right? So yeah, we need the idempotency. And then, okay, no worries. We need idempotency. What we do, let's just put a table in the database. Let's just add the database here, right? That might be our thought. But yeah. Which database to pick up? I guess nowadays that's like when I just need to think about, okay, which database to pick up, I feel some kind of crisis. So you can see here SQL options, no SQL options. So just let's grab a couple of names. Who here worked with the Postgres? Okay. And with MySQL? Less people, but still not bad. And with Dynamo? Okay, so we have different options. I mentioned this one for a purpose. That's mainly the ones that we use in OLX. Not exclusively those, but the majority of services uses Postgres, uses MySQL, uses DynamoDB. That's actually what we did. Okay, let's limit our space to those ones. And the Oscar actually goes to the Postgres, and I will explain why we decided. When evaluating the database, the first criteria was to understand what is the type of data that we can store inside? What is the storage type? And actually the Postgres is not as it was like 10 years ago when you only stored your traditional tables, you know, relations tables and so on. Nowadays you can use Postgres to store JSON. You can use Postgres to store geospatial data, text search data, and so on. So we go with this choice. It was justified. Transactionality, that one is classic, right? We need atomicity, we need consistency, we need isolation and durability. That's out of the box in the Postgres. Next part, query types. And here also would like to make a question, especially for those people that are working with both relational and non-relational databases. Where you have feeling more comfortable on writing queries? Who thinks that on SQL? Can you raise your hand? Okay, and who thinks writing non-relational queries like Mongo or Dynamo? Okay, I have one. Yeah, that's actually not a fair question, I know. But yeah, we use both as I was saying. But that's, in our case, we realized that we prefer using SQL, especially because given the kind of business we are trying to do here, like collecting different kind of data, verifying the data, it would be difficult for us to predict all of the use cases. So it would be difficult to model the problem from the beginning. We are not sure. And we think, okay, SQL gives us more, I would say, more safety in that sense. Latency, and that's one actually, who you think would win in latency? Non-SQL database or a SQL one? Who think that NoSQL is better in latency? Can you raise your hand? Yeah, NoSQL, yeah. You're right, yeah. That's a difficult one to compete, and actually when having the discussion, this was a difficult one to compete. But actually, we don't use Postgres, we use Aurora Postgres, so Postgres inside Amazon. And in some situations which were similar in our cases, like the latency can be not very bad, can be single-digit millisecond latency. Still, NoSQL databases or document-oriented database might be better, but still we can compete, or we can, let's say like this, we can live with it. And of course, scalability. Here also, NoSQL databases are better. But still, for our use case, that was enough, because our major decision driver was the developer experience. Once again, that's why I ask you who is used to use SQL and non-SQL. And as you can see, developers, I wouldn't say prefer, but very many of them are comfortable with writing the SQL. So yeah, and Postgres has some good extensions and plugins. So we solved that problem. We implemented idempotency. You might think, yeah, all good. So, but not, actually. Shit start happening actually when we did some first deployments, because as you can imagine, the data started arriving. We started running some query, verifying the data, but data started accumulating. After a couple of days, our query latency increased like to 1 second. We were producing more data than actually we could export. We started to get clogged. And the worst case is that our product manager, our team was just saying, yeah, but we need to expand to other OLX websites. Right now you are only in Poland and you're stuck. I need to go to Portugal, to Bulgaria, and so on. I want to expand to the motors, So we were stuck. But wait. The problem was one single table. Can you believe on that? I'm talking seriously here. One single table. Have you everyone, or someone here actually saw a table with almost half a terabyte? Can you raise your hand? Okay, cool. I see one person, so I don't feel so bad. So yeah, that's actually what started happening in our case. Yeah, and then we start thinking, then we should stop using Postgres. Perhaps we should switch to non-relational database. But wait. You can think about one thing, which is data partitioning. Who is used here to do data partitioning when designing database stuff? 1, 2, okay, not bad. Cool, but we forgot about this. We initially were a little bit, like optimistic. Yeah, we created indexes, all good. We didn't predict that our services would handle such a big amount of data. So yeah, but Postgres, as I was saying, has a lot of useful extension. There is one called Partition Manager, and there is another one which is called Postgres cron, when you can schedule automatically partition your data. And you can also do another thing which is very critical in our case. You can also schedule the data retention. You can easily drop and delete your data. So our data become to be organized into something like this. We have like table for example, OLX Bulgaria, for Portugal. But even inside we have another level of partitioning. We have a table for Automoto, which is our cars website in Poland. For a specific day, for the specific date. So this amount of data explodes. Virtually, it looks like a single table, but it's not. Actually, each partition in Postgres is like a separate table. So we are alive, actually. We solved the issue. Now we are in production. This screenshot was taken just a couple of days ago, actually. And you can see that our latency was pretty acceptable. You can see here. Of course, not fair enough because it's average. But still, you can see like the most frequent queries that our system is doing. Here, a couple of them, so not bad. And what goes next? The data continues to grow. This is just to give you the example from Braze. You see the data from May this year, 5 months of data, and it's growing, 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 growing. Right now, we are exporting externally 50 billions of data points. 50 billions. This includes your username, your email address, your notification preferences, the stuff that you are checking online. So yeah, and that's not all. We are expanding. We're starting with OLX in Poland. We go into all OLX in other countries. Now we are going to motors, like Stand Virtual, Autovito, Automoto. So yeah. So you might think, so was that the only problem? Well, I could say sure, right? But no. But I just don't have enough time to explain you know, all the other stuff that we have. But what I can say is that how we assure that we don't have issues, or if we have issues, how we assure that we react to those issues on time. We are always keeping the lights on, basically. That's what we are trying to do here. Easy to say, perhaps difficult to implement, but that's what we try to do. And how we do this? Classical approach. Pretty classical. We collect tons of logs from our services and store those logs in the ALK. Who does know the abbreviation of ALK? Okay, nice. That's nice to see this stuff. Nice to see that people not storing all the logs in the server. Yeah. And we also generate metrics, health metrics of our systems. And we export it into our monitoring system, which is New Relic. By the way, also just cross-checking, who has using New Relic? Okay. All right. That's nice. So yeah, we have all of our metrics, health metrics, issues inside of the New Relic. And if something goes wrong, we create an incident automatically. We have a bots for that. And once we create an incident, if you are lucky, you will just receive a Slack message and you can check it on Monday when you start working. If you belong to the second category of people, you might receive a message from this guy here, which is PagerDuty. Who is aware about the PagerDuty here? So yeah, anyone that was woke up at 5 a.m. or 4 a.m.? No? Okay, not bad, not bad. So yeah, we have on-call engineers. And we literally have eyes everywhere. I just want to give you some look and feel. This is like from New Relic. An editor looks like a SQL editor. You can, for example, this is an example. When I was searching if the user was able to disable successfully the notification setting. Basically, when you click on that unsubscribe button on your email, I was checking if users are able to do this successfully or not. And if happens this here, if it's failed, this is a legal issue because you don't want to receive our communications, but we are still sending them to you. And you can see you can check it pretty well in the New Relic. So that's why keeping the lights on is important. Not sending the data can constitute a legal issue. That's the first thing. But still, there is another thing. If we're not sending the data, we can reduce our potential revenue. You might think, how? This is just an email. But yeah, what if you were planning to buy a package in the OLX just on that time, then you gave up on your idea? Sending the right email on that time could be the trigger to change your mind. Let's suppose just one single email, the probability, like the average revenue of a single email is 1 cent. Still, with millions of emails we are sending, there's a lot of money. So yeah, gaps in the keeping the lights on makes our customers unhappy, break our legal compliance, and affect our revenues. And finally, just to summarize, you saw a lot of stuff. I know you are tired. We want to eat something. So that's what we have, basically. Our data generation, our data exchange, our data export system, and we are keeping constantly the lights on. And I just would like to say you one quick thing, which is you could replace this thing with Braze and put here any other marketing partner or provider that you could have, like Google Analytics, for example, or Facebook you could use here, and that still theoretically should work. Of course, theoretically, but because issues can appear, right? So yeah, so what we learned today, is that we start first from the problem. That was our focus, actually, trying to understand what's the problem. It's about communication. We very quickly realized that we are not good in communications. And we found a partner for that, a tool for that, and focus on what we are good in the data. After that, we try to do things as simple as possible, but of course not simpler than that. As you see, we try hierarchically and one by one building system. Just to make you, to perhaps explain it better, our first releases didn't have idempotency. We were kind of experimenting because your product manager says that you need to deliver it fast because we want to reduce the time to market. In some way, they are right, of course. There is always a battle and a trade-off between product and engineering, so we need to have consensus there. So yeah, so we gradually increase the complexity of the system. And finally, we are trying to keeping our lights on. And I hope that right now there is no incident happened, and I want just tell thank you to all of you, and also would like to say thanks to a lot of people that participated on this, and probably I cannot capture all of them here, just a single slide, but some of them with whom we work, some of them with whom we didn't work, some of them with whom we plan to work. So yeah, because we are kind of a data integrator. We agglomerate a lot of data, try to put it into marketing and make the marketing people happy, and consequently our customers. And that's all, guys. I hope you enjoyed. Thank you.
Thank you, Alec. And now finally it's time for our Q&A. So we will start to receive questions from you. And also we can also take a look at this Slido to also ask the questions. And people that is online, please add your questions to the Slido, and then you can answer here. So let's start. My papers. Okay, I don't need this anymore. Sorry, people. Okay. Oh, why? It's not working. Oh, eventually will work. Wait a minute. Do you have questions? Who can start? Do you have? Go. Okay, you have a mic? Okay, go ahead. Okay, you can use mine.
Hello?
Or not.
Regarding the first presentation on Pact, I have a question related to how does it work when integrating with external providers, basically?
So when working with external providers and you are not allowed to implement the provider's tests on your own, you are pretty much doomed because you cannot fulfill the tests. We are using it locally in all our services, and we are only targeting the ones that we own. So for example, in the things that we mentioned before on GraphQL, we have different consumers for providers which are not owned by us or are totally external. For those ones, we are excluding those for being incorporated. Thank you for the question.
Okay. Can you use the mic?
Sorry, just repeating the question. Can't you use the Pact just for the consumer of that external service?
Okay, so I can still use just for the consumer, but what's the real purpose of it? I'm going to have a contract that is never fulfilled, so I never know what's the benefit there. So the mock or the contract in that case is not going to be very helpful. Still, you can do it, but you'll never know if that contract is fulfilled or not.
You can keep the mic, and then you can. Okay. More questions? No? Oops. Okay. So let's
Actually,
get
got
a,
a
oh,
lot
you
of
have one?
questions in Slido.
Yes, we are going to. Okay, so let's start with Slido questions. So, how does Pact handle contract tests?
That's already.
Yeah, though. Yeah, it's true. So, now the second one, do you have Kafka brokers running on top of Oh. You. Both of you.
You can, yeah, sure. About the Kafka, actually, I forgot to mention, no, we don't have Kafka running, on top of, this one doesn't work.
I think so.
Sure, too much. Okay, so we have Kafka, as I was saying, but no, it doesn't run on top of Kubernetes. We are using a Confluent cloud and paying, of course, some extra money for that. Yeah, but that's how it is.
So next one, in the complex pipeline example, how long it takes to deploy a change to production?
So this question, I don't know who actually asked it. It was you. Okay. It actually depends on if we are considering the time for the teams to communicate between each other, or if it's just the time for each of the again. So if it's an issue, for example, on the consumer and the provider team is not available to do the change, and this is when the contract change, right? So it's going to take more time before there will be a need for the provider team to fill it in. Now, if you are asking if adding the Pact into the pipelines, if it increased or not the build pipeline, this is the question. No, it did. So it's very, very short. So the Pact deploy on the Pact broker, it takes around 10 seconds to complete. And unit test is just unit test. So it doesn't take more than it should before that. The publishing to the Pact broker on the contract and so on, it's usually something very short as well, around 10 seconds. So yeah.
In that complex example where you would also check all the services that depend on that contract?
So that's what I'm saying. So if on that complex problem, and when I mentioned that, it's usually because there was a change in the contract. But if there is no change on the contract, the pipeline doesn't take any time because that's going to trigger on the provider. If there was a change, then the provider eventually need to make changes. So that's why I was asking what is exactly your question. Not sure if everyone on the audience understood.
I thought I was imagining, I think wrongly, that you would run some kind of tests against those services that are running, but no, you're just checking the contract and that's...
Yeah. So if on the complex pipeline, if there were no change in the consumer, then the provider doesn't need to run. So it's automatically. And the broker knows if there was a change or not on the consumer contract. Right. What I mentioned before is that if there was a change, then there will be an effort in the provider team to fill in the new changes. I don't know how much time it's going to take. It depends. So I cannot answer that. But the jobs related to Pact, for both the publishing of the Pact and for tagging on the broker, what is the version that is deployed, that, like I mentioned, it's meaningless.
By the way, on the producer side, how do you check that the Pact matches the actual implementation? Is there any validation that the implementation actually answers what they say they should?
So the handler code, I'm not mocking, right? So I never mock the handler, and the handler is the one that responds to the contract. So what I'm mocking is the responses from the service that this handler uses. So this means that my handler is always consistent with the current code that I have, always. So if it fails, it's failing because it doesn't provide the implementation that I need on the contract. So I never mock that part.
Okay, no. What problems have you faced while using Kubernetes? I think you are the person.
I think it's more core tech problem. Yeah, it's more core tech. But one of the problems that we face sometimes is like, for example, when you are making Argo rollouts, many deployments at the same time, sometimes they start to stay stuck because the pipeline of jobs is too big to be deployed, for example. But this is a more core tech team answer than for a backend developer in that sense. So we have no abstraction. In the majority, we maintain our YAML files for all the configurations of Kubernetes in the system. So every repository has their YAML files and the configurations. And you can customize, yeah. But the main is YAMLs configuration, yeah. 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 So we use customize and YAML shard abstraction. So next one is not for me.
All right, so why not use Amazon Redshift or Google BigQuery instead of Postgres? Well, yeah. You see, I mentioned a couple of databases and people already saying, why not using another one? Now you can imagine how are our meetings. As I was saying, as I was saying, basically, we tried to understand, okay, what we use more company-wise, you know, and the majority of databases was Postgres, MySQL, and Dynamo. That's what teams usually use, and then we evaluated the advantages of the Postgres, experimented with this, and there was a time, you remember the slide, then we saw that, okay, that was a really bad decision, we should drop, but it's working. One thing is for sure, nothing lasts forever, okay. Who knows if another day we don't switch our minds and change our minds. We are not perfect, but for now we consider that's the most suitable approach. And as you saw by the latency is working. So yeah.
Perfect. Do you have questions here? We have a lot on Slido, but I don't know if you would like to ask questions here. No? Okay. So, okay. Can you elaborate on the vertical scaling of Kubernetes?
Okay, so in Kubernetes, it's possible not only doing horizontal scaling, that is multiply the number of pods that is in the system, but also it's possible, it's not something that we are using, but it's possible to make the resources to make the higher resources usage for each pod. So for example, if one pod is consuming 10 megabytes of one CPU and 5 gigabytes, it's possible to make it run with 10 gigabytes and one CPU, for example. It's possible to do that. We are not using it, but it's possible to do it vertical scaling on Kubernetes. There is a question, yeah. There was. So the Helm charts normally are maintained by the core tech team, and the YAML file from the Kubernetes cluster is maintained for each team repository. Yeah, the other one. Yeah. Now it's Kafka.
Okay, so about Kafka, what we use? Well, we use Spring Boot, basically. We use the Spring library just to connect there. To be fair, we also used another library like custom-made in-house. We call it Streaming SDK, because it's also because of the matter of security. Because as you imagine, we exchange inside Kafka some private users' data, so our events need to be encrypted also. But aside from that, it could be purely just Spring Boot. Locally, for example, when running a unit test, we just use, Kafka listener annotation from the Spring Boot, and we launch test containers. So a framework for testing locally, and yeah, that's it. Yes, I answered.
Yeah, and the next question is for you as well. Because why not using a lighter, less memory-hungry framework than Spring? Also, it is I/O blocking solution. So.
Oh, sorry. I like these questions. You see, it's never easy to have an agreement. Yeah, I know. Some people could ask me, why not using Quarkus? And other people could ask me, why not using Vertex? Are there people? Yeah, I see a guy using both there. Yeah, you're right. Probably, I think some teams can even use it. Because once again, as I was saying, we are microservice oriented. We try to be. As Paulo was saying, we have some huge monolith, and we try to decouple and remove services from there. So when new services are born, there is always a chance we experiment with other frameworks. And of course, like your experience, when you know about something, you don't want, spending hours and hours on Stack Overflow. Actually, right now it's easier. We have ChatGPT, but still, yeah. So that was the choice for the Spring. I hope I answered. Yeah. If I tried Spring, no, actually no. But there is, I saw already a couple of Slack threads, people discussing about this. So do you recommend what the benefits of Perform? Okay. Cool. Thank you. Yeah. For me. Oh. Do you have any data deletion process for Postgres? If so, can you explain the true process behind it? I love that question because actually, before we did partitioning, even thinking about deleting data was a pain in the ass because a typical SQL database is transactional, right? So each time you execute a delete statement, it creates a lot of archive logs for basically being able to roll back your transaction. So delete operation is pretty slow, especially in the huge table as I was showing you. But once we did partitioning, we delete partitions. And we actually don't delete them, we truncate them. And truncates, you can truncate. You remember the table that actually, looking, the slide is not there. You remember that table that was like almost half of a terabyte. I can execute a truncate statement probably in 1 second. So it's really fast, really efficient. And also, I hope you remember, guys, we use the PG cron plugin, which can run kind of cron jobs inside Postgres. Really easy to configure. And we run a data retention job. Basically, actually we don't run it. I'm inventing here. We have also an extension there. The partitioning extension by default, when you create a partition, you can define the retention policy of the partition. In our case, if I'm not wrong, it's 60 days, basically. After 60 days, the old partitions are automatically deleted. And even there is another option. We don't use it, but partition can be deleted physically, or it can be, disconnected, basically, from the main table. And later, when you decide to delete it. In our case, we just delete it. So putting it simply, it's if I'm not wrong, single SQL statement in your SQL script just saying you need to partition the data with the retention policy of 60 days, and it's executed on a daily basis. And very fast. So okay, that's I think for Paul.
So what do you use as a broker for contract testing?
Okay, thank you for the question. So this one, we are using a self-hosted version of Pact Broker running on top of Kubernetes. New Relic versus Prometheus. I don't know if any of you. All right. So this is a good question. If you are using New Relic, we are using something that is forces us into using one single provider. If we are using Prometheus, we are safe on that part. We can export the data into something else. By the way, nowadays we are targeting into using open telemetry instead of Prometheus or whatever, exactly to be able to get away from New Relics or any specific provider. Hoping this is the answer. I don't know this one, so sorry.
Yeah, just also adding a quick comment about the New Relic versus Prometheus part is that in our services we abstract. We don't have like a code saying connect to New Relic. We have an observability library, basically, and then you can switch a provider, as Paolo was saying. You can use OpenTelemetry for that purpose. And now coming back to the question of Kafka offsets, actually. So yeah, do we store them in the database? Do you still need idempotency to achieve exactly one semantics? That's a great question, yeah, because you might think, why do you need idempotency if Kafka offers it by design? That's not exactly the truth. What Kafka offers us is the possibility we receive a message. If we fail to process it, we don't acknowledge that. Of course, the message is there. But what if, let me say you like this, what if some team is duplicating data? What if some team is creating multiple events with exactly the same data, with exactly the same payload? The event ID could be different, but the payload is the same because there was some issue, some bug. That's why we needed idempotency. What if I say to you that we receive an event, which is just a JSON or our file, and we compute a hash of the payload? In that way, if you send me different events, is exactly the same content, I will still know that that's a duplicate. So I will avoid it. So that's why we need the custom idempotency.
So now, let's wrap up the session, and also a big applause to the speakers. Okay, so that's it. Thank you. Yeah, let's have some drinks and pizza.